Hello guys, welcome to the course series Public Economics, and this is Unit 8, Public Choice Theory. We will see the collective decision making, how it works. We have seen in earlier video the example of majority voting and three preferences. We have seen that no one candidate is able to achieve the majority using the single vote preference. Here in this case, no one candidate is the Condorcet winner. So we will see what are the requirement or conditions. In that case, we can achieve the Condorcet winner. The answer gives the median voter theorem. So median voter theorem puts out some conditions. One is that the one-dimensional spectrum, all election alternatives, all the options should be in one-dimensional spectrum, and the voters' preferences are single picked. So we will understand through this graph or image. Suppose there are three candidates B, C and D. If we put them in a single order A spectrum, and the voters, there are voters, we are assuming voters are in odd numbers. So this is the M is the median voter. There are 4 voters left to this and 4 voters right to M. So the situation here is like this. For this voter, this is the preference. B is the 1, C is the 2 and D is the last preferences. The distance between the voter and the candidate makes the preferences. For this candidate is same B, C, D, and for this candidate C is the first preference and maybe B is the second and then D is the third preference. And similarly for this voter, D is the first preference, then C and then B, because B is the far away from this voter. So all these voters' preferences are single picked. Median voter theorem says that the median voter will decide who will be the winner. The first choice of the median voter will be the Condorcet winner. So in this case we see that up to this level, B is the first choice and C is the second and D is the last choice. So for these voters up to M voters, C is better than D. So because M is the median voter, so including M, this makes the majority 50% plus 1. So majority voter decides that C is better than D. And if we see in this direction up to M, then for all these cases, C is better than B. C is better than B. So in a pairwise comparison, in both ways, C is the winner. As also the first preference of M, the median voter, was C. So we have seen that the C is the Condorcet winner. So it is possible that the majority here, 4 voters are thinking B is the first preference, 4 voters are thinking D is the first preference, and only 1 voter is making C first preference, but still C can be the Condorcet winner if the median voter decides that C is his first preference. So this was median voter theorem. Next is the cost of majority voting rule. So there are 2 costs in a majority voting system. One is the cost of collecting the individual preferences and reaching out the decision. This cost is denoted by D here, and the other cost is the external cost. Suppose there are n numbers of individuals or voters. If there is only one person making the decisions, then the decision making cost, this D, is almost 0. But we are leaving all the n minus 1 individuals, then this external cost is up to maximum. So this decision making cost depends how complex the system is becoming when the number of individuals or voters are increasing. So this decision making cost is lower if one person can take the decision, as the proportion of the persons required to agree on any issue increases. The cost of finding agreement between the winning majority would also increase. So as the number of voters will increase, this cost D will also increasing. Slope of D depends how complex the system is becoming as the number of voters are increasing. This slope of E depends how important is the issue for individuals and how much it is going to affect them. So how we decide what should be the majority which minimizes the total cost. E plus D is the total cost. So our system should be like that. The total cost E plus D should be the minimum. So it is possible that E plus D will not minimize at the intersection of E and D, because this depends on the slope of E and D. So up to this point, when we go from here to here, the D only raises this much, but E has fallen this much total. So fall in A is greater than raise in D. And this the same situation is continue and up to this point. This point makes the equal slope. This is definitely positive slope and this is negative slope, but we are only talking about the absolute value of the slope. So at this point N1, the slope of D is equal to the absolute slope of E. And at this point, this becomes the total cost minimum. E plus D is the minimum at this point. So because in this case, the slope of D was less compared to the falling slope of E in the initial stage. So there could be the another case where the falling slope of E is less in the initial period than the rising slope of D. So in that case, it is possible that the minimum point of E plus D we will find somewhere near to the minority voters. So this means in some cases majority decision is not required. We can achieve the consensus or agreement with the minority winning also. And in some cases we need more than 50%, maybe 60% majority or 75% majority, if that minimizes the cost. For example, in Brexit case, there was simple 50% majority rule. If you analyze this through E plus D graph, where the minimum total cost we would have occurred, so it could be possible that the minimum cost would have occurred at 60%, because the Brexit issue was so important compared to the decision making cost. So it was possible that the majority would have been 60% or 70%, whatever. So in that case, Brexit would not have happened if they have analyzed through E plus D graph, but we don't know that. So this was the cost of majority voting rule, and that's it for this video, guys. See you in the next video, and leave your comment or feedback in the comment section. Thank you, guys.